Okay, you might want to keep this in place. There was a video that talked about the equations that you would need to use given a projectile. And one part did cut off, I believe. I've had kids ask, how can we remember cosine is x and sine is y? And I had Hendrik today in class share how he remembers it. He spelled the word cousin, except for he left out the u. And in this word, cos comes before sine, just like x comes before y. So that's how he remembers it. So if you need any kind of silly little way to remember it, I thought this was a very good way. Okay, moving on. I've got an example problem to cover here, and this is a projectile at an angle. So let's assume that the problem said this ball was launched with a velocity of 20 meters per second at 70 degrees. And that's the only information it's going to give you. And you have to go through and be able to figure out everything that comes next. So I want to show you how I filled this out. The first thing I did, I took my 20 and my 70 here, and I plugged it into my calculator with my calculator in degree mode. 20 cosine 70 gave me Vx naught, 20 sine 70 gave me Vy naught. Once I have Vx naught and Vy naught, I will not use this anymore, so I'm just going to mark it out. I don't want to use that anymore. Okay, moving on from there, I knew that there's no horizontal acceleration because there's no horizontal force. All my Vx's are the same, so therefore Vx is also equal to Vx naught. And then I also knew that as my projectile goes up, the vertical velocity is reduced until it hits 0, and then as it goes down it increases again until it hits exactly what it started with if we have a flat piece of land. Okay, so assuming we have flat ground here. So Vy is also 18.8, just like Vy naught, except for the only difference is Vy is pointing down where Vy naught was pointing up, so I'm going to make Vy negative. Okay, x naught and y naught, where the ball very first becomes a projectile, is the origin of the problem. So x naught and y naught are both 0. If we call the ground level 0 for y, when it hits back down on the ground, finally, the final y will also be 0. So that takes care of how I knew these things. Okay? Vertically, we're both back down on the ground here, 0 and 0. Vertically, 0. X, the ball moves horizontally forward. So I had to calculate x. Before I could calculate x, I did think about vertical acceleration as -10. That's always going to be the case. There's no horizontal acceleration, so horizontal acceleration is 0. So the next thing I had to think about is to get time, because I needed to get time before I could get x. So if I take a look at the vertical velocity, Vy naught equaled 18.8. And it lost 10 meters per second each second that it traveled up. And as it traveled up, if it lost 10 meters per second each second, it would have taken 18.8 divided by 10 seconds to reach the top. So it took 1.88 seconds to reach a vertical velocity of 0. And that's what acceleration is. It's losing 10 meters per second each second that it's on its way up. It's gaining 10 meters per second each second that it's on its way down. It takes it just as much time to rise as it does to fall. So to get the total hang time, I multiplied the 1.88 seconds by 2 to get 3.76 seconds. So that's my total hang time. Okay. Once I knew my total hang time, my only real equation for horizontal motion looks like this. X naught being 0, so I've compacted my equation. And my Vx is 6.8 times 3.76. That gives me x. Okay, let's talk about y max. There's no equation that has y max in it, but if we look at this equation carefully, I can actually calculate where the ball is at vertically at any time I want to. Exactly the same with horizontal position too. If I said how far has it moved in 0.5 seconds, I could plug in 0.5 here and I could tell you how far over it has gone in 0.5 seconds. If I want to know how far over it has gone in 3 seconds, I could plug in 3 here and that'll tell me where it's at horizontally at about 3 seconds. The same thing with the vertical equation. Vy naught and A and y naught, they're all constants. They don't change. But y changes as t changes. So if I plug in 0.5 seconds here and here, that will tell me how high it is at 0.5 seconds. I can plug in 3.76 seconds here and here, and I'll get 0 for y, because at 3.76 seconds it was back down on the ground. So to get the maximum height, I can plug in the time when it was at its maximum height. So it took it exactly 1.88 seconds to hit 0, velocity of 0, which means now it's going to start going back down. So I'm going to plug in 1.88 for time here and 1.88 squared for time here. Vy naught is 18.8. Acceleration -10. Don't forget that negative. It will completely change your answer. So that's how I ended up getting y max. And this is my basic example of a projectile that is launched at an angle.